Hello. Now, today we're going to be looking at the sum and difference, the sum of sines and cosines, and turning them into products. So product means multiply, sum and difference means add and subtract. So we're going to be taking sines and cosines added together and turning them into sines and cosines multiplied together, or vice versa. We're opening up page 15 in our log tables so that we can work along with these questions. And an important note on avoiding negative angles is that we are always going to rearrange these questions so that the largest angle is first. Always put the biggest angle first. So if we look at our first example here, right as a product, sine 4 theta plus sine 6 theta. Well, sine 6 theta is bigger than sine 4 theta. So I'm going to rewrite that as my first step to have the 6 theta first. Now the importance of this is that we never want to have to deal with negative angles if we can possibly avoid it. And we're going to see where negative angles might come up if we didn't do that rearranging. So I know that I have a sum of sines, sine A plus sine B, and I want to turn it into a product. So I go to page 15 in my log tables, and I see that I have a formula for this. I have sine A plus sine B is equal to 2 sine A plus B all over 2 cos A minus B all over 2. And now I can sub directly into that formula. So I'm going to have 2 times sine of 6 theta is A. So I can actually write that as in A would be equal to 6 theta and B would be equal to 4 theta. So I have 2 sine of 6 theta plus 4 theta all over 2 cos of 6 theta minus 4 theta all over 2 is going to be equal to 2 sine of 6 theta plus 4 theta is 10 theta divided by 2 is 5 theta. And cos of 6 theta minus 4 theta is going to be 2 theta divided by 2 is 1 theta. And that's our job done. We've turned that from a sum of terms into a product of terms. Now here is where our bigger angle being first is important. If we had had A as being 4 theta and B as being 6 theta, the way it was originally given to us, we'd have ended up with cos of minus theta here. And remembering the rules and methods for minus angles is an extra complication we don't need. So an important tool in the back of our minds is that we're always going to rearrange so that we have the largest angle first in order to avoid negative angles in our sines and cosines and tans. Now, next example we're going to look at is turning a product into a sum. So going back in the other direction. So write cos 2 alpha sine 4 alpha as a sum. So at the moment we have this as a product. It's 2 terms multiplied together. So we go to our rules for our products. But before we do that, we note that we have the angles the wrong way around. I don't want to have this 4 alpha behind this 2 alpha, so I'm going to rearrange this as sine of 4 alpha cos of 2 alpha. Now you can do this, it's just a reminder, multiplication order does not matter. 3 by 2 is the same as 2 by 3. Just as a reminder, you are able to swap the order of multiplication. So that's what we're able to do here. Now, if we have our bigger angle first, that's now sorted. So let's go to our log tables and see where we have a rule that connects multiplying sine and cosine together. When we do that, we run across an immediate issue, because the rule we've actually got is that 2 times sine of A cos of B would be equal to sine of A plus B plus sine of A minus B. So what are we going to have to do? Well, we're just going to have to divide both sides by 2. So we're going to take the formula in our tables and just divide both sides of this equation, because it is just an equation, by 2. So what we're going to do then is say that we have sine of 4 alpha cos of 2 alpha, 2 alpha, is going to be equal to our A is going to be 4 alpha. Our A is going to be 4 alpha and our B is going to be 2 alpha. So we have sine of 4 alpha plus 2 alpha plus sine of 4 alpha minus 2 alpha, all divided by 2. Because again, our formula requires that we'd have our product multiplied by 2. We don't here, so we've had to rearrange it so that we have our sum divided by 2. And then we simplify that down and we get sine of 6 alpha plus sine of 2 alpha, all divided by 2. And you will also often see this written with the half in front. There is no mathematical difference between these two things. I'm just going to write down the other way that you would see it so that it doesn't throw you off if you see it somewhere. Both of these are mathematically identical. They're both just having the signs divided by 2. Now, putting these rules into a slightly more complicated context, we could be asked to show, or sometimes they'll say to prove, that we have stuff involving sums could be equal to something else. Now, there are multiple ways of trying to approach this question. And I just note that I have made an error in the way I've written that. That should be sine theta. There are multiple ways of approaching this question. The way that is generally best is to take the side that is relatively simple looking and leave it alone as a target that you would aim for. And particularly if you can start to spot patterns when you have used these formulas a few times. We know that if we're going from a sum of sines and cosines to a product, we are going to end up getting the average of the A and the B, so the average of 3 theta plus 1 theta, so we're going to end up with 2 theta as one of our angles, and we have 2 theta over here, and on the other side we are going to end up with 1 theta. And we don't want that in our final answer, but if we spot that we have a sum of terms and at least part of what we're going to get by turning it into a product is going to give us the same number angle as we have on the other side, that's an indicator that we might want to try and use the sum and the product rules, sum to product rules. But let's put this into practice. Again, general principle is if you have something fairly straightforward, so tan 2 theta in this case is the simpler side, leave the simpler side alone and try and use some of your rules from the log tables on page 14 or 15 to try and simplify these down, and a lot of the time you'll find that things cancel and you'll be able to get to the right hand side or the other simpler side. So let's put this in practice. I have a sum of sines and I have a sum of cosines. So I go to my log tables and I look for rules about sums of sines and sums of cosines. So I have sine of a plus b from my log tables now. Sine of a plus b of sine of a plus sine of b even would be 2 times sine of a plus b all over 2 cos of a minus b all over 2 and cos of a plus cos of b is equal to 2 times cos of a plus b all over 2 cos of a minus b all over 2. And now I've written down these formulas, you can possibly see how this question is going to go immediately. I don't need to rearrange my sines and cosines here because I already have the biggest angle coming first. So my 3 theta is going to be my a and my theta is going to be my b in both cases. So let's sub in. I'm going to, on the top line, have 2 sine of 3 theta plus theta all over 2 cos of 3 theta minus theta all over 2. Bottom line, 2 cos 3 theta plus theta all over 2 cos of 3 theta minus theta all over 2. Simplifying down, I get 2 sine of 3 theta plus 1 theta is 4 theta divided by 2 is 2 theta. Rewrite that. 2 theta cos of 3 theta minus theta is 2 theta divided by 2 is just theta all over 2 cos of 4 theta all over 2 is 2 theta cos of 2 theta all over 2 is just theta. I now see that I have lots of common factors that I can divide out by. I have 2 and I have cos theta are both common factors to the top and bottom line, so I'm left with sine 2 theta all over cos 2 theta, which is indeed equal to tan 2 theta. It's the definition of tan. So, general principle, leave the simpler side alone, try and use some of our rules from page 14 or 15 to simplify down the more complicated looking side, and usually you will find a bunch of stuff that cancels out, and you will be left with something that you can simplify to what you want on the simpler side. And